Jack rides a motorbike on a straight level road in a direction due east. The following graph shows his velocity as a function of time. Describe the motion of the motorbike from point C to E. So what we have here is the motorbike speeds up, goes at a constant speed, slows down at a constant rate, same acceleration. At D it stops and changes direction and then continues to speed up in the opposite direction. There are a whole lot of things that could have got you marks on that. You could have talked about C to D slowing down and from D to E speeding up. You could have said a constant deceleration and a constant acceleration in the opposite direction. You definitely had to tell me about the stopping at D and changing direction. Calculate the motorbike's total displacement for the 40-second journey. And now we need to work out. Displacement is, for a velocity time graph, the area under the curve. So I've got a triangle, a rectangle, a triangle minus another triangle over there. And it doesn't take a genius to see that these two triangles are 100% the same. I mean, they've both got 5 as the base and 10 as the thing, and they're in opposite directions. So if you wanted to, you could actually just cancel them right out with one another and then just add the rest. But you could also work it all out and add it together. So it's going to be that you need to write displacement is equal to area under curve. You've now told the examiner that you know something. And it's always good for the examiner to believe that you know something. And then they'll hunt through the rest of your stuff. If you just start going and calculating areas, they are going to land up, they can't give you marks if you get it wrong. So you need to have given a heads up as to what you're planning to do. And then this base over here is 20 multiplied by a height of 10. It's a rectangle. And when I add that all up, it's 250 meters. And in what direction did we start off going? And we still had more above the line than below the line. Don't forget that if I ask you for a displacement, it means I need a direction. Distance doesn't need a direction, or if I said magnitude of displacement, but I said displacement, so I'd have to have a direction. Determine the motorbike's acceleration between C and E. That is, acceleration on a velocity time graph is equal to the gradient. Again, get some marks for writing that. The next thing that we're going to do is we're going to say minus 10. Gradient is y2 minus y1. So minus 10 divided by x2 minus x1, so it's 40 minus 30. And that turns out to be 2 meters per second squared. And what you've got over there is it is a negative value, which means that this is all going in the opposite direction. So that is a westerly direction. An aeroplane has an unknown initial velocity. It doubles its velocity over a distance of 3.5 kilometers if it accelerates at 5 meters per second squared. So we're going to start by saying we need to convert 3.5 kilometers into meters and then get the original velocity. So it's going to be 3,500 meters. Then you're going to say v squared is equal to u squared plus 2as. Final velocity squared is going to be 2x, which is double the original velocity, which is x, plus 2 times acceleration they've given me is 5, and the distance is 3,500. And when I solve for x in that equation, I find x is equal to 108 meters per second. They didn't say I had to convert it into kilometers per hour. They didn't tell me I had to work out 2x. Now it says to me, oh dear, convert this answer into kilometers per hour. My favorite question, 108 meters per 1 second is the same as 0,108 kilometers per 1/3600th of an hour. So I'm going to take 0,108 multiplied by 3,600 in my calculator, and out pops 388,84 kilometers per hour. Last question, what was the time taken for all of this to happen? And we need to now say v is equal to u plus at. I'm going to go I'm going to go with V is 216 now. U is 108 plus 5 times T, and T turns out to be equal to 21,6 seconds. The truck is moving forward at a constant speed of 20 meters per second on a horizontal road. At point X, the driver sees a stationary car 120 meters ahead. At point Y, after traveling at a constant speed for a certain time, the driver applies brakes and the acceleration of the truck is minus 2,5 meters per second squared. What does the negative sign for the acceleration imply about the motion of the truck? That it was slowing down. Calculate how the truck travels after the brakes have been applied at point Y until it stops. So now we need to, how far that truck has traveled. We know quite a lot about it. We're going to go V squared is equal to U squared plus 2AS. I know that it comes to a stop at 2 meters before the, at the point that it stops. Okay, so we're going to just say that the final velocity is 0. My initial velocity they told me was 20. 2 times they've told me an acceleration. And I have got a distance then that is going to be equal to 80 meters. So I know that this guy traveled from the time he braked 80 meters. When the truck finally stops, it is exactly 2 meters from the car. So what can we subtract? We can say we had 120. We know we didn't have 2 because we stopped before that. It took us 80 to slow down. So how many meters were left over? 38 meters. Those 38 meters took place at a constant velocity of 20 meters per second. So I'm going to say time is equal to displacement divided by velocity. The displacement is 38 meters that took place at a constant velocity of 20, and I get 1,9 seconds.